Hello everyone. Today we will going to discuss regarding Diffie-Hellman key exchange. When we are going to consider Diffie-Hellman key exchange, this is mainly used to exchange session key between the two users. So how the session key is exchanged means, in case of Diffie-Hellman key exchange, first both the users will going to consider the prime number q and the corresponding primitive root alpha. So when we know the prime number q and the primitive root alpha, then we will going to select a private key. Let the private key of user A be XA and private key of user B be XB. Okay, and this XA as well as XB must be less than Q, because when we are going to consider the exponents of alpha, so we will going to we can able to generate all the elements between 1 to Q minus 1. Okay, so these many elements we can able to generate using the primitive root. So while selecting the corresponding XA and XB, we have to select the value less than Q, such that we can able to generate the elements within the range 1 to Q minus 1. So using this private key, how we can able to calculate public key? So public key is calculated using the primitive root as well as the private key, and then we are going to use the prime number what we have considered. So here the public key is calculated by the expression alpha to the power of XA mod Q by user A, and similarly user B will going to consider alpha to the power of XB mod Q. Okay, so now using this we are going to get the corresponding public key, where XA and XB are private key, YA and YB are public key. Now in order to get the session key, what we are going to do means, both the users will going to exchange their public key. So now user A is having YB and user B is having YA. So using this, how session key can be generated? So for that, we are going to consider session key is equal to YB to the power of private key of user A mod Q. And here user B will going to take the public key of user A, and for that he will going to consider YA to the power of XB mod Q, where XA and XB are private keys of the corresponding users. So now we know that we can express YB as alpha to the power of XB, and to the power of XA means we are going to get the term as alpha to the power of XA into XB mod Q. Similarly, user B, here how we will going to get the session key means YA can be expressed as user B will going to express YA as alpha to the power of XA, and to the power of YB, XB is nothing but alpha to the power of XA into XB mod Q. So like this, we can able to express the session key. So now both the users are having the same value, that is alpha to the power of XA into XB, and as a result we are going to get a common session key by both the users. This is how Diffie-Hellman key exchange will happen. Okay, now let me consider a problem using calculation of Diffie-Hellman key exchange. So in this, let the primitive value be 6 and the prime number be 271, and the private key of user A be 25 and private key of user B is 39. So when we are going to consider the calculation of session key, we can consider it as two ways, that is using one of the public key and the other private key, or else I can consider alpha to the power of both xa as well as xb. Let me consider the first one, that is ya to the power of xb mod q. So now if we are considering ya to the power of xb, first I need to find out ya. Ya is nothing but alpha to the power of xa mod q. Okay, so now let me express this as alpha is 6 and xa is 25 mod q. So here what happens when we are going to consider this? First, I need to find out the binary equivalent. So using the calculator, we can able to find out the binary equivalent of 25 as 11001. So this is nothing but 2 to the power of 1, and this value is 2 raised to 2. Sorry, this is 2 raised to 0, 1, and 2 raised to 2, 2 raised to 3, and 2 raised to 4. So according to that, we are going to get 16, 8, 4, 2, 1. Now, in order to get 25, we are considering the positional value 16, 8 as well as 1. Now, first I need to calculate 6 to the power of 8, and then I need to consider 6 to the power of 16. That is nothing but 6 to the power of 8 square. If I know the value of 6 to the power of 8, I can directly find out 6 to the power of 16. And whatever the value we are going to get, we have to take mod q. Okay, so now let us find out the value of 6 to the power of 8 mod q. So the value of 6 to the power of 8 mod q is, that is 6 to the power of 8 mod 271 is equal to 1679616 mod 271, which is nothing but 229. Now I can get 6 to the power of 16 as 229 square mod 271, which is equal to 138. Okay, so now let us calculate 6 to the power of 25. That is nothing but 6 to the power of 16 into 6 to the power of 8 into 6 to the power of 1. Okay, because here 6 powers are 16, 8 and 1. If we add all these powers, we will be getting the value 25. So now express this product. For this product, we have to take mod q. So the result what we are going to get is 183. After taking the mod q, we are going to get the result as 183. So now the public key ya is equal to 183. Using this, I need to calculate session key. So let me express session key as ks is equal to ya to the power of xb mod q. So as I told, first we have to express the expression, that is xb in terms of binary. Here xb is 39, and then for that the binary equivalent of 39 in the calculator, we can able to get the binary equivalent as 1 0 0 1 1 1. This is nothing but 2 raised to 0 is 1, 2 to the power of 1 is 2, and 2 raised to 2 is 4, 2 raised to 8 is 0, 2 raised to 2 raised to 3 is 0, 2 raised to 4 is 0. That is the positional value 8 and 16 are multiplied with 0, and 32 is 1. Okay, so now we have to find out the value of 183 to the power of 32, and also we have to consider the value 183 to the power of 4, 183 square, and 183 to the power of 1. So here 183 square mod q. So when we are going to consider 183 square mod q, we can able to get the value as 156. Similarly, in order to get 183 to the power of 4 mod q is nothing but 156 square mod q, which is equal to 217. Okay. So the next thing is I need to find out 183 to the power of 32. So for that, directly if I calculate 183 to the power of 32, the value will be out of the range in calculator. So for that, what we are going to do is, first I am going to calculate 183 to the power of 8, which is easy because 183 to the power of 8 is 183 to the power of 4 square. So I am going to get 217 square mod q. It is equal to 183 to the power of 8 and its value is 206. Okay. So now in order to get 183 to the power of 32, I can express this as 183 to the power of 8 to the power of 4, isn't it? So since I know, because 8 into 4 is 32. So I know the value of 183 to the power of 8. That is nothing but 206 to the power of 4 mod q. So what we are going to get here? We are going to get the value as 126. Okay. So now I can express Ks is equal to 183 to the power of 32 into 183 to the power of 4 into 183 square into 183 mod q. Okay, because here we know that we can express 39 as 32 plus 4 plus 2 plus 1. So as a result, I'm going to consider this product. So now I can write this as 126, that is 183 to the power of 32, and it is 183 to the power of 4 is 217, and 183 square is 156 into next 183 mod q. So what we are going to get? So when we multiply all these value in the calculator, we will be getting the value as 780559416 mod q. So which is equal to 13. So now the session key Ks is equal to 13. Okay, this is how we can able to calculate Diffie-Hellman key exchange to share the session key. So now let us consider the another way, that is to find the session key using alpha to the power of xa into xb mod q. Okay, so here when I'm going to consider alpha to the power of xa into xb mod q, so here I need to multiply xa and xb, that is nothing but 25 into 39 mod q. So we are going to get the exponent as alpha to the power of 975 mod q. Okay. So now what we have to do? We have to express first 975 in terms of binary. Okay, this is in decimal, it's binary equivalent. In the calculator, we can get the binary equivalent as 1, 1, 1, 1, 0, 0, 1, 1, 1, 1. So this is 2 to the power of 0, the value is 1, and 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8. This 16 and 32 are multiplied with 0, and next bit is 64, and next bit value is 128, and the next bit is 256. The next bit is 256, and the next bit is 512. So when we are going to add 512, 256, 128, 64, 8, 4, 2 and 1, we are going to get the value 975. Okay, this is how we can able to express 975 in terms of binary. The next thing what I have to compute is, I need to compute 6 to the power of 2 mod q, which is nothing but 6 square is 36, mod 271 is 36 only. Then 6 to the power of 4 mod q. So we are going to get the corresponding value as 212. And next 6 to the power of 8. 8 is nothing but 212 square mod q. And the corresponding value is 229. Then 6 raised to still, why, even though 6 raised to 16 and 6 raised to 32 are not used, I'm computing, because if we compute this, it is easy to compute the next higher bits. Okay, so for that reason we are computing. So 6 raised to 16 is nothing but 229 square, 229 square mod q, which is nothing but 138. And 6 to the power of 32 is nothing but 138 square mod q, which is 74. And 6 raised to 64 is nothing but 74 square mod q, which is 56. And 6 raised to 128 is 56 square mod q, which is nothing but 155. And 6 to the power of 256 is 155 square mod q, which is 177. And next what we are having is the last one, 6 to the power of 512, which is nothing but 177 square mod q, which is equal to 164. So now we have calculated all these values. The next thing is we have to find out session key. So I can express session key as Ks is equal to alpha to the power of, alpha here is 6. So I can write it as 6 to the power of 975 mod q, which is nothing but 6 to the power of 512 into 6 to the power of 256 into 6 to the power of 128 into 6 to the power of 64 into 6 to the power of 8 into 6 to the power of 4, 6 square and 6. This is how we can able to express the whole thing into mod q. So if I use all these values, the product in the calculator will be out of range. So for that, what I'm going to do means, I'll just express this as 6 raised to 512 is 164 and 6 raised to 256 is 177 and 6 raised to 128 is 155. So only first 3 I'm going to multiply and take mod q, and that result will be multiplied with another, that is 6 raised to 64 is 56 and 6 raised to 8 is 229 and 6 raised to 4 is 212. Okay, so I'll be multiplying these things and I'll going to take mod q, and again the remaining things, that is I need to multiply 6 square, 6 raised to 4 as well as 6 raised to 1. So 6 raised to, sorry, I have used 6 raised to 512, 256 and 128 as 164, 177 and 155. And similarly 6 raised to 64, 6 raised to 8, 6 raised to 4 I have considered. The left out thing is I need to consider 6 square into 6 mod q. After this, I'll multiply all these results and once again I'm going to take mod q. So here for this first term, what I'm going to get, the answer is 198. And that is after taking mod. And for the second term, what I'm going to get is 16. And for the third term, what I'm going to get is 216. Okay, again multiply these things and take mod q. So what is the final answer we are going to get? That is 68. Sorry, here it is 684288 mod q, which is equal to 13. So in the previous in this previous method, that is where I took ks as xa to the power of, ya to the power of xb mod q, I got session key as 13. And the next one, what I did is the another method, that is expressing session key as alpha to the power of xa into xb, and then finding the session key. So both will give the same answer, but here compared to the previous method, this will going to take much time. That is the difference. Okay,